Bit. So this was a mock paper for set two, and we have discussed some questions from this one. So we stopped at this last part D, and the flame test also we have discussed, and the limiting factor, the molecules as well. Okay, question 5. So today we'll discuss mock set 2 and set 3 as well. You can use a chat or you can also use your mic to answer the questions. This is a paper 4 mock set 2. This question is about the rate or the speed of a reaction. A student investigate the rate of decomposition of aqueous hydrogen peroxide. Hydrogen peroxide decomposes into water and oxygen, and we use a manganese 4 oxide as a catalyst. Catalyst is a substance which alter the rate of reaction without chemically change, and it lower the activation energy so the reaction can proceed at a lower activation energy at a higher rate. The student used a stopwatch as shown and apparatus as shown. Manganese 4 oxide is there, a container, and loosely fitted cotton wool is there, aqueous hydrogen peroxide. A student add a catalyst to aqueous hydrogen peroxide. So here he added a catalyst and he replaced the container on the balance and start the stopwatch. So he start the timer and he record the mass at a regular interval, because what will happen? This hydrogen peroxide, it decompose into water and oxygen, but in the presence of catalyst, the rate of a decomposition will be higher. So it will give off oxygen gas. When it gives off oxygen gas, so the mass or the reading on the balance will decrease. In the beginning, we'll have greater mass, but with the passage of the time, the mass will decrease. Table 5.1 shows, as you can see in the beginning, the mass was 50.64. Then it become 49.8, 49.38, 7, 0, 7, 0, 2, 9, 9, 48.97, 97, and 97. So when the mass is not changing, what this given indication? This given indication. Yes, Muhammad Abdul Rahman, you have a question? You can use your mic.
Yes, sir. Sir, when we add the catalyst,
Yes.
so more mass should be lost, right? Because adding the catalyst will cause the reaction rate to be faster, and then more mass should be lost.
Reaction rate will be faster, but the final will be same. Like let's say you were having a hydrogen peroxide H2O2 and you place it on the balance. And the second experiment, you did the same experiment, but in the presence of the catalyst. So the final mass, the change in the mass will be same. Like example, if the original mass, the initial mass for the experiment was 50.64 grams, then at the end of the experiment, the mass will be 48.97. For this one as well, it will be 50.64, and at the end of experiment, it will be 48.97. But what will be the difference? The difference will be the time. So the difference will be the time, like this change in the mass in a short time. Let's say this took 200 seconds to show a change in mass without a catalyst. Like if we were having a catalyst, it took 200 seconds to show this change in mass. Without a catalyst, it will take much longer time, maybe 400 seconds or more than that. So the final change in the mass will be same, but the time interval, the rate of a reaction will be altered. This is for those who just joined now. This is mock paper 4 set 2. So suggest why the mass decreases as the time increase. The main reason is that because the oxygen gas escape or the gas escape, that's why the mass will decrease. After a certain time, the reaction stop. Why the reaction stop? Here we have only one reactant. So instead of, because what is a reactant here? Hydrogen peroxide is a reactant. Some of the student mentioned limiting reactant used up. limiting, you use the term limiting reactant when you have two reactants like A and B are forming a product C. One will be the limiting reactant, another one will be an access. When I have two reactants, yes, I do use the term limiting reactant used up, but in this case it's a thermal, it's a decomposition and we have only one reactant. So whenever you see only one reactant, you should name that reactant instead of saying limiting reactant used up, because the limiting reactant is a comparison between the two reactants. So should mention, instead of mentioning limiting reactant used up, you should mention hydrogen peroxide used up. Suggest why it is not possible to use the results in table 5.1, determine the exact time when the reaction stop. So why we cannot determine the exact time when the reaction has stopped? What could be the reason? If you see, when we are recording this, we are recording the time interval. Yeah, look, we are recording. First, in the beginning, we record the mass. Then after 30 seconds, we record the mass. Then after 60 seconds, we record the mass. After 90 seconds, 120, 150, 180, 210, 240, and 270. So we are recording the rate, like the change in the mass after every 30 seconds. So if we were recording after 1 second, like every 1 second we were recording, but it is practically impossible to record any change or any value after every 1 second. So it's very like difficult technique to record the values for every 1 second. So student was recording after every 30 seconds. So this, because the recording is done after every 30 second, that's why we don't know exactly when the reaction stopped. If we were recording for every 1 second, like 0, 1, 2, 3, 4, which is practically impossible. But what if we were doing that? So if we were recording for every 1 second, we can exactly tell at what time the reaction stops. But if we are using this method with a 30-second interval, that's why it is impossible to know exactly when the reaction stops. So it suggests why it is not possible to use the result to determine the exact time. So the answer here, that the student record the mass with interval of 30 seconds, which is too long to exactly know the rate or the change in mass. Is it clear, this one? That why it is not possible to determine the exact time when the reaction stops?
Yes, sir.
The next is figure 5.2 shows how the mass changes against the time experiment repeated with a higher temperature. If we carry out at a higher temperature, the reaction will be faster, but the change in the mass will be same, so it will be much steeper. So it will be much steeper. So this will be the graph. Explain in terms of collision theory why a rate of a reaction is higher at high temperature. So it's a structure answer which you have to learn. You have to write. It is fine that you are using your mic, or you can use chat, or you can also annotate on the screen to answer. I accept this. And if you use mic, I prefer that you're using a mic so you just convey your point. So if I explain in terms of the collision theory, why the reaction is faster at a high temperature.
At high
Sir,
temperature,
because when we increase the temperature, the thermal energy converts to kinetic energy. So particles move faster, and the rate of collision increases, increasing the rate of reaction.
And one more point, which important point you missed.
frequency of collisions increase.
And no, another thing, very important point, where temperature increase, greater proportion of particle have energy more than activation?
Is this point necessary?
Yes. The point that greater proportion of the particle have energy more than activation whenever you refer a temperature. Higher temperature, greater kinetic energy or speed of particle, more collision or more successful collision, and greater proportion of the particles have energy more than activation energy. So this is very important to include. Manganese 4 oxide is catalyst in this reaction. Manganese, this is 4. So what is this? Explain the meaning of a Roman 4 here. So that is representing the oxidation state of, yeah, it is representing the oxidation state. Um, it has lost 4 electron, that's fine, but it's in a Roman because sometime it's fine you mentioned it is losing, but the distribution, it's mainly when a Roman number is there, it is representing the oxidation number. And what is the oxidation number? It's plus 4. So it lost 4 electrons, so the oxidation number is plus 4. State how the mass of the catalyst has changed, if at all, at the end of the experiment. Catalyst, the mass does not change at all.
Didn't
This is
change.
yeah, because catalysts only alter the rate of a reaction without chemically change. So there is no change in the mass of the catalyst. If you use, look, if you use greater mass of a catalyst, the rate will be faster. Like if I use 2 grams of the catalyst, another experiment, I use 4 grams of the catalyst, definitely 4 grams of the catalyst will be higher rate than 2 gram. But the final product or the amount of the catalyst at the end of the experiment will be same. It won't change. The nitrogen monoxide NO and oxygen gas reacted to produce a nitrogen dioxide at a room temperature. The reaction can reach an equilibrium. Equilibrium means the rate of forward equals to rate of backward, and there is no change in the concentration. And the enthalpy change is negative. Delta H is negative. What this indicates? If delta H is negative, this indicates the reaction is exothermic. One of the student asked how the catalyst lower the activation energy. Yes, I will answer that point. Look, a catalyst, what it will do, let's take an example of ammonia. Formation of ammonia when a nitrogen reacted with a hydrogen, it gives off ammonia, 2NH3. That's the balance equation. Without a catalyst, nitrogen is a gas and hydrogen is also a gas. Nitrogen is having a triple bond and hydrogen is having a single bond. And we need 3 molecules of the hydrogen. So 3 molecules of hydrogen must collide with 1 molecule of a nitrogen to give off ammonia. How the catalyst lower the activation energy? Because first the bond should break between the nitrogen and hydrogen and then they should combine. So how the catalyst work? When we use iron as a catalyst, the iron will trap the hydrogen on the surface. When the hydrogen is trapped on the surface, the bond energy, the energy, like example, in a gaseous state, when it was alone, maybe the bond energy is 200. But when this hydrogen is trapped on the surface of the iron, the bond energy is only 100 because it is stick to the iron. So the bond can easily break down. So when we move the nitrogen gas over the surface, the nitrogen will collide with these 3 molecules of a hydrogen and gives off ammonia. So the presence of the catalyst trap the one of the reactant on the surface and the other reactant move over the surface. So the bond can break down and it will form a product. That is why if this reaction was happening at maybe 200 at in activation energy, the same reaction will happen at 100 of activation energy. But again, this is not a part of syllabus at all. Like they will never ask you how a catalyst work. But this is just an information I add some points. Explain why the method shown in figure not will not allow the reaction to reach equilibrium. Look, equilibrium what we should have in an equilibrium, we should have a closed container. Means the reactant and the product should not escape. Like if we have a nitrogen monoxide is there and we have oxygen is there and it will form a nitrogen dioxide. So the reactant and the product should not escape the mixture. Then it can only reach an equilibrium, or we also call that we should have a closed system. We should have a system which is not affected, like which is not having any interaction directly or not losing or the reactant or a product. But why this method will not allow it to reach equilibrium? Because what will happen, the nitrogen and oxygen, when they react, they will give nitrogen dioxide, but the gases can escape. The unreacted nitrogen monoxide and oxygen can escape, and the formed nitrogen dioxide can also escape. So because they're not in a system, closed system, that's why it will never reach an equilibrium. Equilibrium you can only reach when you don't allow the reactant and the product to escape from the system. So we must need, if I want it to reach an equilibrium, then what I should do? I should take a closed container. I should have a container which does not allow these gases to escape. So nitrogen monoxide is there and oxygen is there. I supply once and then I will stop. After supplying nitrogen monoxide, oxygen for some time, and then I will stop, and it will form a nitrogen dioxide. There will be unreacted nitrogen and nitrogen monoxide, and eventually it will reach an equilibrium. But if the system is open, it will never reach an equilibrium because the reaction mixture can lose the reactant as well as the product. The apparatus is changed and the equilibrium is reached. The temperature of the equilibrium system is then increased. The position of equilibrium shift to the left. Why the position shifted to the left? If you see the original reaction, the forward reaction is what? Exo. So you will write here because why the position shifted toward the left, because the forward reaction is exothermic. So when forward reaction is exothermic, we have reactant and product, and whenever we increase the temperature, the equilibrium will shift towards the left hand side, or we'll get more reactant. The pressure of the equilibrium system is then increased. State the direction. If we increase the pressure, you have to check the moles of the gas. So here we have 2 + 1, 3 moles of the gas, and here we have 2 moles of the gas. So increasing the pressure shift the equilibrium or the balance towards side where number of moles are less. So if we increase the pressure, the balance or equilibrium will shift towards the right hand side because fewer moles of the gas in the reactant side. So equilibrium shifted towards right, and the reason is that you should mention fewer moles of. If you only say fewer moles, that is not the complete answer. You should always relate, whenever equilibrium is related by pressure, always use the term gas, like moles of the gas. This question is about the hydrocarbon. State the meaning of the term hydrocarbon. What is the definition of a term hydrocarbon? So hydrocarbon means a compound which contain carbon and hydrogen only. You can use a screen annotation to answer these questions. Propene, which is C3H6, can be made from a long chain alkanes such as dodecane. Dodecane contains 12 carbon. So because it's an alkane, the number of hydrogen should be twice plus 2. So 12 plus 2, 12 multiplied by 2, 24 plus 2, it will be 26. And it is producing a propene. So C3 and H6 is there. And another product will be there. Deduce the molecular formula of dodecane because the number of hydrogen twice. Name the type of a reaction. We call that as a cracking. Then propene is unsaturated hydrocarbon. Propene react with the bromine. State the meaning of the term unsaturated. Unsaturated in organic compound means contain a carbon-carbon double bond. Some students I saw, they wrote it is insoluble. But this is insoluble is correct for the solution, for a solute which does not dissolve in water. So in this case, don't use the term unsaturated as insoluble. Use the term that No, this is 3,6 should be there. Yeah, that's right. Because what will happen? We have C3H6 and it reacted with a bromine, which is Br2. It will undergo addition reaction. So it will form C3H6 and Br2. There is no double bond here. Why there's no double bond? The structure is, this is propene. Prop means it contain, this is propene. The structure, it contain a double bond. When it reacted with bromine, Br2, the two bromine will break the double bond and it will attach with a carbon. So whenever alkene reacted, it will turn into alkane, the double bond breakdown, and this is a product. So the molecular formula for product, 3 carbon, 6 hydrogen, and 2 bromine. So there is no double bond here. Yes?
Sir, for unsaturated, can we say that it has a double bond only?
But you specify, this is also double bond, oxygen-oxygen double bond. So you have to specify
So
that it contain a carbon-carbon double bond.
will we lose the mark if we don't specify?
Yeah, because it should be.
Okay.
Because double bond can be between oxygen, double bond is there. So even in a carbon dioxide, carbon is bonded with. So there should be a carbon-carbon double bond we call unsaturated hydrocarbons. Then determine the empirical formula. Empirical formula shows the simplest ratio between the molecular formula C6, C8H8. So the empirical formula, what is the ratio between 8 and 8? It's 1:1, so it is CH. Can be polymerized. State the type of polymerization. Whenever alkene undergo a polymerization, it is always addition polymerization. No need to mention no water. It's the thing is whenever you have alkene undergo addition polymerization, and we have to state the type of polymerization. Then draw the structure of one repeat unit. Draw the structure of the one repeat unit. So we have to include all the atoms and all the bonds. C6H5 group should be represented as C6H5. So you don't have to break that. So when its monomer is already written as like letter H. So we will draw the same structure. Yes, we will just break the double bond and turn into a single bond. But no need to put a bracket and write N. Why? Because they ask us the repeat unit. They did not ask draw the polymer. If they said draw the polymer, then what I should do? I should put a bracket and write N. Okay. So this was mock set 2. We'll start 3 as well. D1. D1, the molecular formula is C8H8. Empirical formula means the simplest ratio. What is the ratio between 8 and 8? You divide it by the common factor. So 8 is the common here. So we divide by 8. So 1 C1 and H1.